we are going to discuss how to use the concept of fuzzy sets to solve a variety of real world problems. We have already explained the grammar of fuzzy sets, and let us see how to utilize that fuzzy set to solve a variety of problems. Now, as I told that we are going to concentrate on application of fuzzy sets. Now, in this lecture actually we are going to concentrate mainly on two applications. One is how to design and develop fuzzy reasoning tool in the form of fuzzy logic controller. Now, if you see the literature, we have got two very popular approaches. One is called the Mamdani approach and another is called Takagi and Sugeno's approach. Now, both the approaches will be discussed in detail with suitable numerical examples. Then we will concentrate on fuzzy clustering. Now, clustering is done based on the concept of similarity. Now, two similar points should belong to the same cluster and two dissimilar points should go to two different clusters. Now, let us see how to use the concept of fuzzy sets to design and develop the clustering tools. Now, this I have already mentioned that the concept of fuzzy sets have been used to develop fuzzy reasoning tool like fuzzy logic controller, then fuzzy clustering, and if you see the literature, the fuzzy sets have been used for fuzzy mathematical programming, then comes fuzzy graph theory and others. Now, here I am just going to concentrate on how to design and develop fuzzy logic controller or fuzzy reasoning tool. Now, the first notable approach developed in this particular the direction is by Mamdani and Asilian. Now, Mamdani and Asilian in the year around 1974-75, so they developed one fuzzy reasoning tool or fuzzy logic controller. The purpose was how to model the input output relationship of a process. Now, this Mamdani approach, if you see the working principle, so the performance of the fuzzy logic controller depends on the knowledge base, and this knowledge base consists of database as well as rule base. Now, let me first define the concept of this database and rule base. Now, let me take very simple example, very practical example. Supposing that, so for this lecture room, so I want to control the temperature and humidity, and I want to keep the temperature and humidity within a very reasonable range or very acceptable range. Now, let us see how to control with the help of one air conditioner. Supposing that I have got one AC here in this particular room and I want to control the temperature and humidity of this particular the room. Now, the first thing we will have to do is we will have to find out or we will have to identify what are the variables, the design variables. Now, the design variables could be something like this. For example, say the temperature of this particular room, humidity of this particular room, the temperature outside the room, humidity outside the room, thermal conductivity of the wall, number of people sitting in this particular room. So, these are all the variables or these are actually the design variables. Now, supposing that for simplicity, let me consider that I will have to develop one fuzzy logic based say expert system, which is going to control the valve opening of this particular air conditioner, so that the temperature and humidity remains within the comfortable zone. So, let me consider for simplicity there are two inputs, one is the temperature T and another is the humidity H, and the output is nothing but the angle of the valve opening for this particular the air conditioner. Now, let us see how to define the database and the rule base if I want to design and develop one fuzzy reasoning based tool or fuzzy logic controller. So, here the inputs are the temperature and humidity inside this particular room, and output is nothing but the angle of valve opening for this air conditioner. So, what we do is we try to define some range for the temperature. Now, supposing that, so this is nothing but the range for the temperature, this is the minimum temperature and this is the maximum temperature. Let me consider the minimum temperature is a 10 degree centigrade and the maximum temperature is a 50 degree centigrade. And what we do is, so this whole range of temperature that is expressed with the help of some linguistic term, and for simplicity let me consider that I am using only 3 linguistic terms. Now, supposing that the linguistic terms are as follows. For example, say I am just going to say this is the low temperature, this is the membership function distribution or the fuzzy set for the low temperature denoted by L. This is the membership function distribution or the fuzzy set for the height, say medium temperature M, and this is say for the high temperature, say that is your H. So, H prime. So, we have got low temperature denoted by L, the medium temperature denoted by M, and your high temperature denoted by say H prime. So, this is nothing but the membership function distribution for the temperature. Similarly, for the humidity, what we do is, say we defined the minimum and the maximum value for this particular humidity in a particular scale and using some unit. So, let me assume that, let me put some numerical value, say the minimum is 5 and say maximum is 25 in certain scale and using some units. And once again, supposing that I am just going to use say 3 linguistic terms. So, if I use 3 linguistic terms, one is say L, that is low value of humidity, another is the medium value of humidity that is denoted by M, and another could be your the high value of humidity and that is denoted by your H prime. So, the whole range of humidity that is expressed with the help of 3 linguistic terms, one is low, another is medium and another is high. So, L, M and H prime. So, this is nothing but the humidity. Now, this is what we mean by the database for the temperature, and this is nothing but the database for your the humidity. Now, similarly, I can also construct one database for the output, that is nothing but the angle of valve opening. So, this is the angle of valve opening, say denoted by A. Say I know the minimum value, I know the maximum value, and once again I use say 3 linguistic terms, say your one is say small denoted by S, another is say the medium say denoted by M, and another could be your the high, that is the high angle or the large angle say denoted by your say L r. Okay. So, this particular your the range for this angle for the valve opening, so that is divided into or that is expressed using 3 linguistic terms. One is small, another is your medium M and another is your large, that is denoted by L r. So, this is what we mean by the database of your some variables, say inputs or the output variables. Now, using the concept of, so this particular your database, now I can define the rules. Now, here there are 3 linguistic terms for temperature and 3 linguistic terms for this humidity. So, 3 multiplied by 3. So, there will be actually the 9 possible rules, that means 9 possible conditions for the input variables. Now, out of those 9, so if I just write only one, supposing that the rule could be something like this. So, if your temperature is low and the humidity, that is H. So, H is your say medium, then the angle of valve opening, that is denoted by A, is nothing but say small. So, this is one rule, and similarly as I told, there could be 3 multiplied by 3. So, there could be a maximum of 9 rules. This is what we mean by the rule base. So, rule base consists of 9 rules, a maximum of 9 rules, and out of the 9 rules, here I have just written a particular one. For example, let me repeat, if temperature is low and humidity is medium, then the angle of valve opening is small. So, this is a particular the rule. So, this is the way actually we define the database and rule base of this particular the fuzzy reasoning tool, and knowledge base consists of both the database as well as the rule base. Now, here I am just going to make one comment that the performance of an FLC largely depends on the rule base, and optimizing the database is a fine tuning process. Now, here the presence or absence of a rule, that is going to dictate the output of that particular fuzzy reasoning tool in a very large way. On the other hand, if I see the database optimization, that is nothing but the fine tuning process. Now, let us see what do you do during this particular the database optimization. Now, if I consider the database is nothing but this type of your triangle. So, if I consider this type of triangular distribution for this particular database, so this is low, this is medium, and this is your the high. So, what we do is during the optimization, we try to say either increase or decrease. So, this particular the base of the triangle, that means I will be getting some sort of flatter triangle, or I will be getting some sort of the smaller or the steeper triangle sort of thing. Now, during the optimization, actually we can vary the width or half base width of this particular the triangle, and by doing that we are simply doing some sort of fine tuning. So, this is the way actually we do some sort of fine tuning just to improve the performance of this fuzzy reasoning tool. Now, if you see the literature, so this fuzzy reasoning tool or fuzzy logic controller has been divided into 2 groups. Now, one is called the linguistic fuzzy modeling, and another is called the precise fuzzy modeling. So, linguistic fuzzy modeling and this precise fuzzy modeling. Now, let me try to explain what do you mean by the linguistic fuzzy modeling. So, by linguistic fuzzy modeling, we mean those fuzzy modeling where we have got high interpretability, but low accuracy. Now, let us try to understand what do you mean by this interpretability of a rule. Now, let me just write down one hypothetical rule. So, if I1, that is the first input, is say low, and the I2, that is the second input, if it is medium, then the output O is some sort of say high. So, if this is a rule, the moment I read this particular rule, so I will be able to understand what is the control action. So, if I read if I1 is low and I2 is M, then output is high. So, immediately some control action is coming to my mind, that means its interpretability is very good. That means the understandability of the meaning of this particular the output for a set of input is very high, and that is what we mean by interpretability of a particular rule for the fuzzy reasoning tool. Then comes the accuracy. Accuracy is nothing but the precision, that means the accuracy in prediction of the output for a set of inputs. Now, the example for this linguistic fuzzy modeling is nothing but the Mamdani approach, which we will be discussing in much more details. Now, then comes the precise fuzzy modeling, and here we get low interpretability, but we will be getting actually the high accuracy or the precision. Now, the example is nothing but the Takagi and Sugeno's approach of fuzzy reasoning tool. Now, in Takagi and Sugeno's approach, the way we write down the rule is as follows, like if I 1 is low and so this is not the operator and this is the conjunction and I 2 is your medium, then output is expressed as a function of the input parameters, that is your I 1 and I 2. Now, so this particular output could be either the linear function of the input parameters or it could be nonlinear function, and the coefficient of this particular function, those things will be determined with the help of some optimizer, with the help of some training scenarios, and that is why we can give a guarantee of high accuracy. But interpretability is low in the sense, if I just read this particular the rule, no control action is coming to my mind directly. So, if I read if I 1 is low and I 2 is medium, then output is a particular function of this particular your I 1 and I 2, and let me write that. So, this is nothing but A 1 multiplied by I 1 plus B 1 multiplied by I 2 plus C 1, and if I just write this particular output something like this, no control action is directly coming to my mind, and that is why the interpretability of this type of fuzzy reasoning tool is less. Now, I am just going to discuss your this Mamdani approach in much more details. Now, this schematic view, this shows actually the working principle of the Mamdani approach of fuzzy reasoning tool. Now, if we want to implement the Mamdani approach of this fuzzy reasoning tool, the first thing we will have to do is, so you will have to concentrate here, that means the process to be controlled, and we will have to identify what are the condition variables and what are the action variables. That means, here what are the inputs and what are the outputs. Now, let me once again take the same example, like the temperature and humidity control of this particular room with the help of one air conditioner. And here the inputs are, as I mentioned, the temperature and humidity inside the room, temperature and humidity outside the room, then comes your the thermal conductivity of the wall and the number of people sitting in this inside this particular room. So, these are all condition variables. And what is the output or the action? The output is nothing but the angle of valve opening, so that we can keep the temperature and humidity of this particular the room in a very comfortable zone. So, the first task is we will have to identify the inputs and the outputs, that means your condition variables and the action variables. Now, these condition variables are also known as antecedent. So, this is known as antecedents, and the action variables are known as your consequence. So, antecedents and consequence, so we will have to identify first, and once we have got these particular antecedents, that is the condition variables, we go for the fuzzification module. So, by fuzzification module actually we mean that corresponding to a set of inputs. So, we try to find out what should be the membership function value. Now, let me take a very simple example of the same example of temperature. Now, if I consider there are three linguistic terms to represent the temperature. So, this is the low temperature, this is actually the medium temperature, and this is say the high temperature is say H prime. Now, here, so this is the temperature, so this is 10 degrees centigrade and this is say 50 degrees centigrade. Supposing that the room temperature is around say around 20 degree or something. So, might be I am here. So, might be I am here. So, if it is so, so what you can do is I will have to find out corresponding to this particular temperature, what is the membership function distribution for the low and what is the membership function distribution for your the medium. So, this is the membership function distribution corresponding to the low temperature, and this is the membership function distribution corresponding to the medium temperature. Now, this particular task of determining the membership function value is nothing but is your the fudgification. Now, once that particular fudgification has been done, next we concentrate on your the fuzzy inference. Now, let us try to understand the utility of this particular the fuzzy inference engine. Now, let me take a very simple example. Supposing that the same example of the expert system or fuzzy logic based expert system to control temperature and humidity. Now, as I told that we consider a maximum of 9 rules which are present in this particular the rule base. Now, supposing that for a set of inputs at a time, there could be a possibility there could be only 4 fired rules. Now, out of these 9 rules, which 4 will be fired, that is decided by your this particular the fuzzy inference engine. So, depending on the set of inputs, which 4 out of these maximum 9 rules will be fired, that is decided by your the fuzzy inference engine. Now, once you have got those 5 fired rules, now for each of these particular fired rules, so I will be able to find out what should be the output, and that I am going to discuss in much more details. And once you have got that particular the output of each of the fired rules, so I will be able to find out one output, and that is nothing but is your the fuzzified output. So, here I will be getting the fuzzified output. Now, this particular fuzzified output will be nothing but an area, which I will be discussing much more details after some time. Now, this output is nothing but an area. For example, say if it is triangle, so there could be a possibility I will be getting this type of truncated triangle. So, this truncated triangle shown as the shaded area is nothing but the output of a particular rule, but here there is no such crisp value. So, what I need is a crisp value corresponding to this particular the area, and how to find out that particular crisp value. To find out the crisp value from this particular your fuzzified area, we take the help of some defuzzification module. Now, a few defuzzification modules are available in the literature, and we will be discussing all such things in much more details with the help of some numerical examples. And once you have got the crisp output, that is nothing but the actions to be taken. For the same example, like here the output will be the angle of the valve opening, whether it is clockwise or anti-clockwise, and by how much I will have to just rotate, and what should be the valve opening, whether it is plus 10 degree or minus 10 degree clockwise or anti-clockwise. So, that I will have to decide as the action variable, that is nothing but the output of this fuzzy reasoning tool. Now, here so whatever we discussed, so all such things I have written it here. Now, the first task, let me repeat, is actually I will have to identify the condition and the action variables. So, the first task will be your identification of the condition and the action variables, that is nothing but the antecedents and consequence. And once you have got that, now for a set of inputs, we will try to find out the membership values, and that is nothing but the task of fuzzification, and that is the fuzzification module. And once you have got that, now next we go for the inference engine. I have already discussed the purpose of inference engine. Out of all the possible rules, depending on the set of inputs, which rules will be getting fired. So, that will be decided by this particular the inference engine. And once you have got that particular fired rule, for each of the fired rules we will be getting the output, and then we combine how to combine, that I am going to discuss in details. And once you have got that particular fudgified output, then how to determine the crisp value corresponding to that particular the fudgified output, so that we get some crisp value corresponding to the output and we can control that particular the process. Now, let me repeat once again the purpose of designing or developing. So, this fuzzy reasoning tool or fuzzy logic controller is to find out the relationship between the inputs and outputs of an engineering process, so that the moment we supply a set of inputs, I should be able to determine the set of outputs, so that we can control that particular the process very accurately. Now, how to design and develop, I am just going to discuss in much more details with the help of some numerical examples. Thank you.